Yeah, my name is Oleg. I work at Docker on the DevRel team, and we're going to talk a little bit about building AI applications and what people usually do and what I see talking to people building AI stuff, and how maybe to think about it in a more productive, future-proof way. So very often when you build AI stuff and workflows or anything, people, when they show it to you, is just a bunch of interactions with a chat, right? Normally, all AI agents that we see have a chat interface of some sorts. And this is very, very natural because the promise of the AI ecosystem largely is to replace AI replacing humans. A classic example of that would be to replace the customer support person with just an automated chatbot. Or if you're building workflows, very often you will see the interface where it's a chat, and then you type something in, and it triggers something. And the AI does some computation, maybe some planning, use some tools, and then comes back to you with an answer, and you're like, oh, sweet, perfect. You are my travel agent, and you gave me an itinerary, or you are my financial advisor, and you verified my wild idea to make money on the stock market. And that is a very promising and a fun way to think about AI, but it's also, personally, I think it's very, very limited. So what is much more probable in the future is that AI will start replacing parts of the applications, parts of the software, some components which do fuzzy computation, but it will be driven by the larger applications. And this is something that we heard at the keynote by Mistral as well, right? Where the sentiment was, like, you cannot just sprinkle AI on top of your systems and, like, it magically works. Like, it would be cool if that was the case. And it might be the case if our models will become smarter, which they might or might not. But currently, it's still hard because the data is separated, and you need to build integrations, and you need to build some sort of figure out the rules, what components and who can have access to what parts of the systems, right? And then the words were not said, but it's what it means that you have to build applications. And there will be an AI component that does this magical thing that you cannot put in code, but it will be a part of your application, larger application flow. So it's unlikely will be a chatbot in the future, but currently it is. And currently, when we build agents, it often starts with the local experiments and the local assistant UI, and we're gonna talk to it. We're gonna connect a model to it. For example, GPT models for ChatGPT, or like you have Claude with your Claude desktop, and you start doing some things, and you will be like, "Ooh, I would like you to help me doing X," and then the model will come to you with responses, and it's like, oh, I cannot do X because there is limiting factors. I don't have data. And you're like, OK, I'm going to give you data. I'm going to plug in tools. Thankfully, we have the whole ecosystem of MCP tools. We're going to plug them in. And then you experiment with a couple of system prompts, and then you sort of can externalize what works into the combination of the tools and the agentic application to run this, and the system prompts, which sort of is the business logic. And this is the components for every AI agent that currently exists, is those three things. You need to connect the brains of the agent. You need to connect it to the tools, which will be probably separate applications, either running locally as MCP servers or remote MCP servers, but they are separate components. And you need to connect it to some business logic that is usually described as system prompts. So those three things create an agent. And if you look at that, and you squint, you will see a distributed system, a distributed application where actual brains are a remote API call to the model, and the agentic application is your main driver for interacting with the remote APIs, and the tools are just the data access things, which not strictly speaking fair for MCP, because MCP is not just the USB adapter to plug into the data systems elsewhere, right? MCP provides you a way to have your AI computation have a deterministic expressed in code parts. Right? If your AI agent needs to wire money across bank accounts, you would probably like the money transferring code be actually precise, written line by line, rather than AI generating like a random transfer order. So those three things. It's a distributed application, and very, very often, like you can represent it as like this, right? So you have an agentic application. You will have the language model, which is the current cycle for AI, and then you will have the tools, which are sort of the proxy to databases and other data sources. And then your user will talk to this agentic application, and everything runs. And you can do this locally, and you can build those components, but it is actually very much an application. And what Docker is very, very good at is enabling developers build applications. And not just build applications, but run other people's applications, either locally or in containers in production. So what we would like to do is we would like to go through a bunch of initiatives that Docker has in AI ecosystem, and I would like to just introduce them to you. And then we can see how those kind of sort of map into this picture of how we build agentic applications like this. And then hopefully that will get us closer to how we build normal applications, usual applications. And then that will give us a more insight into how we deploy those things to production. Right, so first of all, there is models, right? And you have the remote models. And for AI agents, usually what you do and what I do is I start with the most capable AI model that it can run for the particular task. I don't want to start with something small and dumb that will probably fail. I start with the most expensive, most capable one, and then verify that, yes, AI is helpful for me on that particular task. And then I will try to optimize it down. And very, very often, this still will be a remote execution call. But for some models, for smaller large language models, you can run them locally. There are a number of ways to do that. Docker has the Docker Model Runner component, which is a part of Docker desktop application, or you can also run Docker Model Runner in the Docker CE environment if you want to run it in Linux. And that is a part of the open source thing. And what it gives you the ability to run LLMs locally on your host within your Docker environment, which is very convenient because you can build your applications, and if they rely on some AI component, you can also run it as a part of that environment. So if we look at the simple example here, where's my terminal? I can do Docker model list, Docker model list. I was informed that there's a break after this, so you're mine for an hour. Nobody leaves, and I have all the time in the world to make all the typos. So similar to how I have Docker images, which represent other people's software packaged in the convenient format that I can get to my machine locally, and I can run them locally easily. I have the same capacity now with models. So if I do Docker model list, and then, for example, I'm going to take some, which I'm going to take. I'm going to take this Qwen3 Sloth model from Hugging Face directly. So normally, we store models on Docker Hub, and they are stored as OCI artifacts. So you can also make models as the first-class citizens in your internal application pipelines, right? Like you don't need to use external services. You already deploy and build applications into your OCI registries, and you can get models there as well. There is a format. You put the GGUFs there, and then you can run them. So here, the simplest thing is I can do Docker model run and give the model name, and I'm in the interactive chat. Hello. Right? And it will run. You will see that, OK, you didn't see that. Let me do it again. Write a JavaScript program to say hello world, and you run it with the argument AI engineer Paris. So I'm going to run this, and we're going to look at GPU. Do you see the GPU spikes? Running locally, which is very, very good. This, of course, cannot run any programs because it doesn't connect to anything. It's just a chat. But this is an example, right? I can run my models locally. There is an OpenAI API-compatible endpoint. So if my application depends on some AI components, right, I can run it fully locally in my isolation and my other auxiliary services that I need, all within the context of Docker desktop. And I have my models there. And I can even see some debugging data, like prompts going in, out, and so on. So we want to make it very, very easy to work with local models, which helps when you want to build deterministic agents, because you do want to control the actual model. And you cannot do that with state-of-the-art managed models because you don't control them. And then one of a sudden, one day, OpenAI can suddenly say, like, oh, GPT-5 is super great, so we're deprecating GPT-4. And your agentic workflow suddenly become different. But with the open source models that you can run locally, and of course you are not going to ship MacBooks to run in your production, but you're going to run containers with this technology in production, you can be in control of the actual what model is doing, its resource capacities, and so on. The hope there is, very much so, the local models are currently kind of dumb. They're not bad, but they're also not state-of-the-art, which is very, very unfair, because they're super capable, but we're all spoiled by the sort of the ChatGPT experience. How many of you run Claude? Everyone runs Claude. Mostly everyone runs Claude. And it's fantastic, right? It's super smart. It can edit your code base. It can give you answers to all the questions. It can go search internet. It's super, super capable. So local models in comparison are not so capable. They're slow, and they're kind of stupid, unfortunately. But they are lagging around 2 years behind the current state of the art. So the current state-of-the-art local models are as good as ChatGPT 3.5-ish, right? Or Gemini 1.5 Flash. And if you remember yourself, 2 years back, when those models, cloud models, were announced and were there, you were like, I'm going to build so many amazing things with this. This is fantastic. We have never seen anything like this. This is super cool, right? And now we look at the local models that can do the same things, and we're like, this is trash. So unfair, but you can build systems with this. They are very, very capable. You just need to experiment and trust in them, and be ready to deal with some latency because they are kind of slow. Right. So this is the models, and this takes part of that top component, which was the large language model. Then the second part, which is even more interesting, is the tooling, and we want to plug the tools to actually make our agents affect change in the world in some sense. We don't want to just to chat with the thing. We want to do something for us. And this comes as a form of MCP servers, which have their design decisions in how they were announced when they came out and how they were made. But they're very, very useful. And everyone, almost all the vendors, are building MCP servers to connect their data platforms. People are building MCP servers for internal resources. People are building MCP servers to do predictable computations. And it's a very, very rapidly evolving ecosystem. So Docker, with the same ease that we did for application development and sharing applications with Docker Hub, we also have, of course, a very natural progression for that. There is an MCP catalog, which is the catalog of MCP servers that is curated by Docker, and it's backed by open source repository that lists MCP servers. But the whole premise of that is that you don't want to run the MCP servers always yourself. Sometimes you want them to be remote, but also sometimes you want to be able to run them. And when you run them, you want to run them with some sensibility. Friends don't let friends run random npx commands on their machine, giving them root access to everything you own. Right? So a sensible way, maybe they're not the most secure, and some security people will be like, Oleg, containers are not a secure boundary. But if you run MCP servers in containers, it gives you at least the predictable boundary for security. So there's an MCP catalog, which is the servers, and then inside Docker desktop, or as a form of Docker images that you can run in your production-like environments, there's, of course, the MCP toolkit for the tools. So you can look at the tools, and you can find your favorite MCP servers. You can configure them. Docker toolkit, MCP toolkit, builds and manages secrets for you. So it only configures and runs servers and gives them access to whatever they need to have. You can enable them very, very easily with just a bunch of button clicks. You have configuration. You can do also OAuth configuration for servers that support that. We support remote MCP servers if you want to. But in a nutshell, after that, Docker desktop becomes the MCP server for your end environment. And then it can give you access to tools. We also do some security on top of that. So when there are tool calls or tool outputs, the toolkit can look at that and find, for example, leaking secrets or malicious instructions that tools do, or any attempts to do tool poisoning, and so on, which is better than nothing. I mean, I'm not a security person, so I'm conservative in my estimates. Personally, I think it's kind of amazing, but it's definitely better than nothing. And it's very sensible, and it's very easy to run your things like this. So if I have my, let me just start my Claude. Connecting pieces together is very, very simple and fast. I cannot start my Claude because there is no internet. I would show you that there are tools from the Docker desktop there. So there is that. And then the third part to that is, so here's the thing, right? What we built the system where the tools are in the Docker, and there is a gateway in the middle, which is a Docker thing, and your application runs in the Docker container, and your large language model runs in the Docker container or with the Docker model runner. So everything runs in containers, which is fantastic news, because that's how we run applications. So if we now gather this into a single thing, we get a format where we can be like, our AI agent is just a bunch of containers that I can give to any DevOps person, and they will know how to run it. So not only I can build my agents locally for myself, connecting Claude to random MCP servers, running like NPX processes, but I also can build agents that actually can be deployed and shared with people, and they can use them and run them. So here's the thing. It's very unfortunate that the internet kind of is lagging, because there was a very cool demo. I'm going to show you a different cool demo. So here's my little Docker compose, because that's how you orchestrate a bunch of Docker services together. And this is exactly, there are three things for our agent, right? We have the service application, our agentic application, that I'm called Honey, because it's goose in Estonian. I'm from Estonia. Today you learned. Honey means goose in Estonia, one of the most important takeaways here. So I run it as a service, and then I connect it to the MCP gateway, which is the MCP toolkit that we saw, but in the declarative composed way. I'm going to say, I would like to run gateway, and I would run the YouTube transcript service. And I'm going to plug the local model that I run locally and define it in my compose. And now what I can do with this, I can take my terminal, and I can do docker compose run, up. And it will build my system out of those components. And then if I go to the port that I'm exposing here, right? So if I go to my containers, I will go to my port. I have my agent, which is Goose, which is AI assistant, open source one, by Block. And I can ask it to do things. And I can do say hello to AI engineer Paris. Normally, I would ask it to use the YouTube transcript MCP server to go and transcribe a YouTube service for me, right? But I don't think it can go. I don't think it can open YouTube due to the lack of internet. Yeah, no, maybe. Okay. Fireship MCP. Come on. OK, it's fine. So I can encapsulate declaratively my agent out of building parts. And then you are not going to run compose in production, unlikely, right? But it uses the same primitives that you are going to run in production. And I can show you multiple examples for this, and they will all be the same, right? So here's a compose example that uses crush for the same thing. Crush is the coding agent in the terminal. I have my crush. It depends on the gateway. It uses models. My gateway connects to the MCP toolkit. and specify some tools so I can work with GitHub through my agent. And it has some models that I am running locally. The same thing. I can run Docker Compose app, and it's there. There's a whole repository with examples called Compose for Agents. And there are examples using all the popular agentic libraries and frameworks, and they all boil down to the same. You have the agentic loop application with one or multiple clients, multiple agents, have the tools, have the models. You can externalize them and put into different Compose files. You can run multiple of them at the same time with a single command. And then it becomes a fantastic way to distribute and run your applications. We're out of time, so I'm going to show you these slides very, very quickly to the end. So there is Compose for Agents that you can run, and your LangChain and your ADK examples and your Babel examples. How many of you are sort of application developers versus AI engineers? OK, so what languages do you use? Java? Anyone? Not a lot? Python? OK, personally, Java. It's a lovely language. Fantastic for enterprises. But we love all languages, so it's fine. As long as it's container-shaped, you're good. So Compose for Agents. Recently, Google Cloud Platform announced that Cloud Run supports Compose. So you can take your Compose, say Cloud Run, run Compose, and you get the whole serverless environment with Compose there. So you can actually run Compose in production. But it's also what we recently did on top of this effort for doing Compose things. We released the C agent, which is the runtime for building agents, where there is a even smaller YAML. So you take this Compose, and there is a DSL for writing agents, and you just specify those three things: tools, instructions, and models, and that's your agent. And you do C agent run, and it runs your agent. It's just a YAML file. Anyone, even marketing people, can edit those agents. I've built an example agent that I made marketing team to use, which I count as my personal success story. And it's wonderful and simple to use. You can push and pull agents to GitHub, to Docker Hub the same way. And it solves the distribution problem nicely. So the takeaway is, if you build AI agents, what you actually are doing, you're building AI applications or applications using AI. And you can think of this, that the AI part is magical, but the application part is heavier, and it will outweigh your system. And you need to use tools that you use for application building when you're building agents. And that Docker is there to help with a bunch of initiatives that you can check out, and that would personally make my day very much. So there are QR codes there. Thank you so much. We're out of time. Thank you.